Hello and welcome to this talk on AWS IoT, part of the AWS Innovate online conference. My name is Kapil Pense and today we are going to talk about leveraging IoT at the edge of the network with a focus on industrial workloads. We are going to look at some real use cases from our customers and then deep dive to understand how the AWS IoT platform enables these use cases. Whenever we talk to our customers about IoT, we like to start the conversation with a question. If you knew the state of everything, every asset in your possession, and if you could reason on top of that data, if you had the capability to process all that data, what problems would you solve? We have made it our mission to make the two conditions in this question come true by providing our customers the ability to know the state of everything and by providing them the tools necessary to reason on top of that data. We are empowering our customers to focus on solving their business problems. One of our IoT customers is Konecranes. They specialize in manufacturing and servicing of cranes. One of the challenges for them and their customers was about applying updates and patches to their machinery on the field. Every such update meant downtime for the machinery and required on-site presence of someone from Konecranes. This was impacting business operations and also presented a logistical challenge for Konecranes, whose machinery was deployed at remote locations across the globe, for example, shipyards, mines, and manufacturing factories. Using AWS IoT and Greengrass, Konecranes were able to deliver updates to their machinery over the air and eliminated downtimes and the need for on-site presence. Stanley Black and Decker is another customer of AWS who has leveraged AWS IoT platform to solve their challenge of data ingestion, storage, querying, and analysis. Much of their equipment is used by their customers at construction sites or rural areas where network connectivity is often unreliable or sometimes not even available. AWS IoT and Greengrass enables Stanley Black & Decker to monitor and filter their data at the edge of the network, enabling applications to send asset health and predict any mechanical failures before they occur. Edge-based applications built on AWS Greengrass help detect and compare vibrations emitted by high-value tools to historical signatures that indicate everything from normal operations to imminent failures. And so instead of trying to ingest and use all the data in cloud, Stanley Black & Decker utilize Greengrass to process the data where it is generated. Now, let's take a few moments to familiarize ourselves with the various AWS IoT services. Amazon FreeRTOS and AWS Greengrass are edge-based software that allow our customers to securely connect their assets, gather data, and take intelligent actions locally, even when the internet connectivity is down. AWS IoT Core, Device Management, and Device Defender are cloud-based services that allow customers to quickly onboard large and diverse fleets of devices, maintain fleet health, and keep their fleets secure. We help them reason on top of their IoT data with services like AWS IoT Analytics that allows our customers to easily analyze their IoT data. It integrates seamlessly with Amazon QuickSight for visualization and Amazon SageMaker for hosted machine learning. Furthermore, all AWS IoT services are built serverless, which means our customers take full benefit of elasticity of the AWS cloud to build their enterprise applications, and they don't have to worry about scalability or utilization, truly only paying for what they really use. So what does this mean for you? It means that no matter what business or industry you are in, AWS IoT can help you extract value from your connected devices. We announced AWS Greengrass in reInvent 2016, and we have been astonished with the breadth of use cases that customers and partners are bringing to us across industries. Industrial gateways from manufacturing and logistics, consumer gateways and consumer devices, connected automotive vehicles, connected wireless infrastructure, energy, agriculture, insurance, medical, mining, almost any industry you can think of. We looked at a couple of customer stories at the beginning, Konecranes and Stanley Black & Decker. Both are stories of how our customers used AWS Greengrass to solve their business challenges, and the use cases continue to grow. Nokia, for example, saw a need in the industrial IoT space to analyze video streams at the edge and send the processed and filtered data to remote centers only when anomalies were detected. As the cost of bandwidth is expensive, especially in remote locations like oil rigs, this has allowed Nokia to optimize the data that is sent to the cloud based on rules and alerts set up locally to process the data locally. Let's take a closer look at AWS Greengrass, which seamlessly extends AWS to the devices so they can act locally on the data they generate, while still using the cloud for management, analytics, and durable storage. Most IoT data never reaches the cloud primarily for three reasons. First is the law of physics, latency and last mile connectivity. Latency of sending data packets to the cloud and getting a response back can be unacceptable for scenarios that involve timely automated decision making, for example, crash avoidance and medical alerts, or equipment that is operating in remote environments, for example, mining sites or in-flight aircrafts or ships that are at sea. Some decision making, such as high value safety critical processes, must continue to operate autonomously when internet connection is not available. AWS Greengrass provides tools for communication among cooperative devices that are interconnected over local networks and capability to execute application code on these remote devices, enabling you to create autonomous applications. Secondly, there is the law of economics. The cost of bandwidth is not falling as fast as cost of storage and compute. AWS Greengrass provides tools for locally aggregating and filtering data, making it easy to act on lower value data locally and upload to the cloud only the high value aggregated data for analytics and storage. The third set of challenges is compliance and privacy. For legal or compliance reasons and concerns around privacy, some industries prefer to store or duplicate data locally. For example, hospitals may be required to keep all records locally even if they are also duplicated in the cloud. Some governments impose data sovereignty restrictions on where data may be stored. In 2016, when we introduced AWS Greengrass, we launched it with the following features: local actions and local triggers to enable a local ensemble of IoT devices to coordinate and operate autonomously. Data and state sync capability allowed Greengrass devices to synchronize their data and their state with the cloud whenever internet connectivity is available. And we brought the security model that we have in the AWS IoT cloud service to the edge of the network by enabling Greengrass to identify, authenticate, and communicate with other local devices securely by acting as the local certificate authority. We have continued to evolve the service, and as you can see today, we have much more. Greengrass now has complete over-the-air update capability, which allows you to remotely update not only the data or state or Lambda functions running on your devices, but also the Greengrass software package itself. We have implemented a protocol adapter for OPC UA, which is a very common protocol used in industrial IoT. The local resource access feature makes it possible for your application code running on Greengrass to take advantage of resources like GPUs, cameras, and various sensors and actuators that might be available on the devices locally. And we have also introduced a powerful new feature called machine learning inference, or ML inference for short. It's a mechanism for you to train machine learning models in the cloud and deploy them to run on Greengrass devices at the edge to process the data and take actions autonomously. You might ask, what can you do with machine learning at the edge? It's really up to your imagination. AWS Greengrass ML inference enables several use cases. I'd like to highlight just a few of them. Think about agricultural companies. During harvest, they could apply machine learning to quick sort different produce and different quality of produce at the farm where it is being harvested, rather than having to transport everything back to the processing facility and storing and sorting it there. In industrial environments, you could apply machine learning and robotics during the manufacturing phase. And towards the end of the manufacturing, you can use machine learning together with video cameras to determine the quality of manufactured goods and decide whether to pack the goods or for shipment or to discard low quality goods. Video surveillance and image recognition to provide timely alerts without costing a fortune to transmit all the video to the cloud. So how do you make this system intelligent? If you were to do machine learning today, you would start by building and training a model in the cloud, which is a compute intensive job. For most applications, you will also run inference and predictions in the cloud. Largely, much of the machine learning you see today, it's done through the cloud. But you can't always do that. There are challenges associated with cost and latency of data transfer, as we saw earlier. So we have taken a different approach to solve this problem using Greengrass and machine learning. The first part, the building and training of machine learning models, which is a compute intensive job, you would still do in the cloud as you have been doing. However, you deploy the trained machine learning models on a Greengrass device at the edge. Then, whether the device is connected to the internet or not, the device can run inference on top of the data on the device itself, and it can take actions locally. Greengrass ML inference relies on deeper feature of Greengrass, which is now also available for all developers. It's called local resource access. Local resource access lets you extend the common programming model of Greengrass, that is the Lambda functions that you deploy on Greengrass devices, and lets them interact with the underlying capabilities of the Greengrass host device. For example, a GPU, a sensor, an actuator, or a bus. And in this way, the Lambda functions that are written in the cloud and deployed down to the Greengrass devices can start to interact with the devices and the physical environment around them. So now, for example, if I'm deploying machine learning models on devices, I can accelerate my predictive models by taking advantage of the GPU capabilities of the device. Another feature of Greengrass is its support for an industrial messaging protocol called OPC UA. OPC UA is a popular exchange protocol that is used in factories, transportation, logistics, and more. It defines the way that devices in, for example, a factory are meant to interact with one another. If you want to use Greengrass in an industrial environment, you would want Greengrass to interact with other devices that are already deployed in that environment and already speaking whatever protocol it is that they are speaking. And OPC UA is a very popular one. So with the new OPC UA adapter for Greengrass, Greengrass can interact with existing fleets of devices that speak that protocol and also the new devices that you might deploy. They can do it in a way that is highly secure with certificate-based mutual authentication between Greengrass and the local OPC UA server. And the implementation of OPC UA that we provide is fully customizable by you, because we've learned that enterprises and developers who use protocols like OPC UA, they get very particular about how it's configured. Speaking of manufacturing and industrial environments, the fourth revolution in manufacturing is well underway. Industry 4.0 is driving a number of initiatives such as performance optimization, failure prediction, and preventive maintenance. These initiatives underscore the need to bring large fleets of interoperable devices under a single ecosystem of cooperating devices. That represents a big challenge in its own, because in most cases, industrial environments are brownfield environments with a lot of legacy equipment that is difficult to replace. These devices often speak many different protocols, but the predominant protocol is OPC UA. Greengrass, with its support for OPC UA, can be used to create this single ecosystem to enable cooperation between existing and new devices. Also, the local resource access feature of Greengrass can be leveraged to implement additional protocol adapters for devices that do not speak OPC UA. A number of opportunities open up when you have a single ecosystem of cooperating devices. At the very minimum, it makes it possible to implement real-time monitoring, which provides business decision makers the visibility they need to make data-driven decisions. It also becomes possible to use the IoT data from this ecosystem to make accurate, actionable predictions about what will happen in the future. And we can build a new breed of smart applications using these predictions. It's really exciting. We are seeing three popular use cases emerge from industrial IoT. By knowing the state of machines, we can improve asset utilization and productivity of a factory through optimization. By combining data from machines with machine learning techniques, we can predict when a machine will fail. Not only that, we can also prescribe the likely fix and schedule a maintenance operation just in time with automatic allocation of right replacement parts and personnel. We can also use machine learning to examine the quality of manufactured products that are coming out of the manufacturing line and monitor the overall health of the system. You might ask, why is this important? It's because this enables product as a service business models where you pay for the yield or offer managed machines as a service. It is important also for smart manufacturing, where market pressure is increasing the demand for customized products to differentiate from competition. This translates to smaller and smaller manufacturing batches, even lot size of one, without sacrificing production quality. Adapting a production line parameters on the fly was traditionally a no-go, but industrial IoT mechanisms open up the opportunities to do so. Let's look at how AWS Greengrass and the broader AWS cloud can be used to implement each of these three use cases. The first one is asset condition monitoring. Here, we want to create a system that continuously collects device state information from all the devices in an industrial fleet. This is a reference architecture for this use case. On the left-hand side, you can see Greengrass device connected to several industrial devices. The Greengrass device communicates with the wide variety of devices by leveraging local resource access and protocol adapters such as the one for OPC UA. The Greengrass device acts as the gateway to communicate local fleet status with the AWS IoT core in the cloud. Devices data from the fleet of devices is continuously streamed to the Greengrass. Applications written in the form of Lambda functions run on the Greengrass device to process the data locally and send only the important high value data to the cloud. This includes changes to the states of devices in the fleet. Rules are configured in the AWS IoT core to trigger notifications to users when interesting events occur on the manufacturing floor. For example, when a particular device starts to experience vibrations above a certain threshold. AWS IoT Analytics service is also used to detect anomalies in the data being received in the cloud. Notifications are sent to users via the Amazon Pinpoint service, which can deliver notifications via email, SMS, as well as push notifications to mobile apps. AWS IoT Analytics service also integrates with Amazon QuickSight, which is used to create a graphical dashboard to visualize the current state of all devices. Now let's look at the predictive maintenance use case. In this use case, we need a system that can continuously examine data from devices and predict failures before they occur. That is, predict that a machine is going to fail before business operations are impacted. Here is a reference architecture for such a system. It builds on top of the previous architecture with the addition of machine learning. The data is streamed to AWS IoT Analytics, is used to train a machine learning model that can predict failures. Amazon SageMaker is used to train the machine learning model, and the trained model is deployed to the Greengrass device using the Greengrass ML inference feature. Notice that this is an iterative process, so that you can periodically retrain the model using SageMaker to improve the accuracy and efficiency and redeploy the model to Greengrass. On the Greengrass device, if the device has a GPU, that GPU can be leveraged by the machine learning model for even better performance. The third use case that we talked about was predictive quality. This is a system that holistically monitors the output of the entire manufacturing line instead of monitoring individual equipment. Once again, we build on top of the previous architecture. And here, instead of training machine learning model to monitor factory equipment, we use cameras and sensors to capture images or readings of the completed products that are coming out of the production line. This data is examined by a machine learning model that is trained to detect defects or to infer the quality of the products. Like before, this model can be iteratively improved using SageMaker and image or sensory data sets residing in Amazon S3. So, to summarize, while Industry 4.0 initiatives are driving the momentum towards more and more industrial IoT applications, these solutions are often complex and multidimensional. At AWS, we have created AWS IoT, Greengrass, and a broader suite of technologies to help our customers securely connect any number of devices to the cloud. We provide the infrastructure that is necessary to scale the solutions so that our customers can gain insights into their industrial IoT data, and so that they can build IoT applications and services that better serve their customers. Now we are going to show you a video of a demo that was built for the AWS Summit in Sydney, which happened a few weeks back. In this video, you will see my colleague Tim Cruz placing boxes on a conveyor belt. Some boxes are in good shape, others not so much. You can imagine this to be the final stage in a production line where finished products are coming off the conveyor belt. Greengrass running on an industrial PC, in this case a Revolution Pi, is the brain behind this solution. It runs a machine learning model that is able to tell whether it sees a product that is in good condition or a product that has some defects. Here is a closer look at the processing unit that you will see in the next video. It's a Revolution Pi that looks like this, and here is another industrial PC. This one is the C6015 IPC from our partner Beckhoff Automation, which is capable of running AWS Greengrass. For more hardware products that are certified to run AWS Greengrass, please refer to our website at aws.amazon.com/partners/IoT-hardware. Now, let's take a look at the demo, and I will explain what is happening as you watch the video. So here you see a conveyor belt which is controlled by the control unit mounted on the pillar next to where Tim is standing. As he places boxes on the conveyor belt, the boxes pass under a camera that takes photos. The photos are analyzed by a machine learning model running on AWS Greengrass inside the control unit. The results of the analysis are displayed on the TV screen. Here we have simplified quite a bit. So the results simply state whether it's a good box or a bad box, but you can run very sophisticated machine learning models that can infer the quality with much more granularity as required by your business case. The way this demo works is there is a proximity sensor placed along the conveyor belt. It is placed just before the camera, which is mounted on an articulated arm. As the box passes by the proximity sensor, the sensor tells the camera through Greengrass local messaging feature to take a picture. The picture is then sent to a machine learning model running on the Greengrass device to make an inference about the quality of the product that is seen in the picture. And as I talked about earlier, this is an example of a safety critical process which must be able to operate autonomously, taking real-time decisions on its own. So here, when the door is opened, the control unit running AWS Greengrass detects that as a safety hazard and immediately stops the conveyor belt. It is important to note that this demo is not connected to the internet and it is operating on its own fully autonomously. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. To learn more about APN partners and to find the right one that fits your needs, please visit the AWS APN booth at our showcase. I hope you found this session interesting. Please complete the event feedback form so that we can improve the experience for you. And finally, I would like to thank you once again for attending today and sticking it out until the very end of this presentation.